Good morning, grade 12s. Welcome to my channel, and let us do the trigonometry portion. So we've done the analytical geometry part. Now let's get to the trig. Okay, so trigonometry is a beast, is it not? Yes, it is. So let me just show you 3 things that you need to master trigonometry. We need to know our order of operations. Obviously, this is brackets, ordinals, but sometimes you just combine it and say brackets of division, multiplication, addition, and subtraction. Obviously, we always do the reverse operation in a way. If we're given multiplication, we undo it by doing division. And if we're given division, we undo it by doing multiplication. Addition, we undo it with subtraction. Subtraction, we undo it with addition. Okay, so this is basically the direct application of that stories. But if we look at the same thing in terms of applications, this could mean reduction formulae, or it could be even core functions. Okay, so here we just divide in common factors basically, and then the AS section would essentially be looked at as special angles, using special angles. Okay, so this is the most important. And then the second thing to think about is factorizations. Okay, we've got 3 fundamental ones. The highest common factor, doing the difference of 2 squares or dots, and then doing any polynomial. I'll just say polynomial of different orders. And the key to this one is nothing but long division. But of course, a special trinomial would be a quadratic, which we can just do by factorizing using the bracket method. But even that bracket method literally came from long division. Unfortunately, this is not the time to prove anything, but just know long division provided us even that quick method of doing a quadratic trinomial. So this is what we need to do. And then the third thing that we need to know, okay, maybe let's pull this one in. So the third thing that we need to know is identities. Sometimes I would include laws for algebra. Any law that you may think of, logarithmic laws, set rules or laws, ordinal rules or laws, or what you call exponential laws, anything. So this essentially helps us with algebraic simplification and perhaps solutions. And you can see trigonometry is nothing but some form of algebra, but looked at in a geometric sense. Okay, so let's go to question 5 without wasting too much time. So question 5, we have 5.1. We are told here that the tangent of 12 degrees is Q. Okay, now we always show this as a ratio, so this is Q over 1 when it is standing alone. Now this helps us to do a terminal arm on the Cartesian plane. So this step, guys, must be done without needing a second invitation. 12 degrees, it's an acute angle in the first quadrant, unless stated otherwise. Okay, if no further modifying statements are given, that should be that angle over there. And since this is 90 degrees, this should be 78 degrees. Okay, we need to do that easily without needing someone saying it. Okay, so that's it. Now, how do we define tan is opposite over adjacent? So we want to find the terminal arm. So we first write out the law and we explain what it is. It's Pythagoras. So r squared is going to be 1 squared plus q squared. We're moving fast. Therefore, r is going to be the square root of 1 plus q squared. And that's it. So that calculation becomes very important. Okay, let's start answering. 5.1.1. We have got cos of 192 degrees. Okay, what is that? It's a big angle. So reduction formulae. Can you see our three-step approach here becomes our friend? So we start here. So okay, we've got reduction formulae. So what do? We first show how this angle got constructed. It's 180 degrees plus 12 degrees. Then we reduce. Cos in the third quadrant is negative, so this becomes minus cos of 12 degrees, which we can then solve by saying this is going to be minus into 1 over the hypotenuse, which becomes the square root of 1 plus q squared, okay, which is equal to minus 1 over the square root of 1 plus q squared. So usually in grade 12 at this point we don't really need to rationalize that denominator, but sometimes you may be directed by perhaps saying prove that cos of this is some other funny version of this. Then obviously once you get to this step you may need to rationalize to get to that particular answer. So be on the lookout. But normally we do these direct ones like this where we may need just a reduction formula, if not, say for example, cos of 78 degrees, which is more direct. So knowing that this reduces to that is important, and the answer and this calculation gives us the 3 marks. 5.1.2. We need to do cos of 24. So with this question, we may get a direct question, maybe needing just a reduction formula or the other angle, but we will definitely need to use identities at some point. Okay, so be very ready. Be it compound, it's usually there, and the double angles, they're usually there. But don't hold on to that only, because you never know. A whole lot of other things can be done. You can be given this expression, but you may need to sort it out using that diagram there. So there's a lot of ways in which questions can be popped here. But what is cos of 24? This is the same as cos of 2 times 12 degrees. Can you see? We need to relate that angle to these ones here. So what do we have? This is the double angle for cos, so this is nothing but cos squared 12 degrees minus sine squared 12 degrees. That's the most basic or defined expansion for a cos double angle identity, but we can have modifications using the square identity. At this point, it's not really necessary to waste our time here. So we just go on and substitute. So we have q over the square root of 1 plus q squared. Now we sort it out, so there's nothing to sort here. So this is 1 plus q squared. Oh yeah, there is indeed something to sort. This is squared. Mistakes. Can you see, guys, when the question is so approachable, it's easy to forget smaller things. So this means this one is out. Okay. So we have minus, we're going to have q squared over 1 plus q squared. Then What did we do here, guys? First of all, we saw that this is an identity, so we used identities to double check it. Then we did our substitutions, and then we go back to BODMAS. What are we dealing with? Like terms, and in terms of fractions, so we look for the common denominator or the LCM. Now here we have a common denominator, so this becomes 1. I don't know what I'm writing there. 1 minus q squared. So this is going to be 1 minus q squared, and in fact I think we can leave it at that. There's no need to simplify further, okay, because that is a difference of 2 squares, but this is not, so you may run into problems. So essentially, knowing this expansion is important. How many marks there? 3. Okay, we can say substitutions and the answer. So normally, guys, when we use our BODMAS applied, we get marks, but when we're doing just direct stuff like addition and subtraction, it's not really mark worthy. Reduction formulae, we get marks. Special angles, we get marks, okay? Identities, we get marks. So let's do 5.1.3. This one, we are given 1 minus 2 sine 6 degrees. Sorry, 2 sine squared 6 degrees. What is this? We can see that this angle is half of 12. So this is a double angle identity, expansion. Of course, perhaps 2 times 6 degrees. So this is the same as the cos of 2 times 6 degrees. So if it is expanded, we contract it. And this is the same as cos of 12 degrees. And what is the cos of 12 degrees? It's 1 over that square root 1 plus q squared. And again, here we don't need to simplify further. So this action here of using identities is key, and then we substitute. As you know, substitutions, or even the final answer for that matter, becomes important. Okay, easy, guys. So this one is a very simple question, nothing really to worry about, but remember, it can get a bit challenging if the examiner decides to pull in some tricks. So this is usually very easy, so let's sort it out. 5.2. all right, so we've got this expression. So we've got 2 sine squared x minus 180 degrees times cos of 180 degrees minus x. Okay, and then here we've got cos of 90 degrees plus x sine x minus cos of x minus 90 degrees times sine of 720 degrees plus x. Okay, so let's have a look at this one and see what we can do about it. Okay, guys, so unfortunately the MotoGP race was quite interesting, so I had to watch. That's my favorite sport, eh? Okay, let's get to this question. So what are we doing here? So obviously, guys, some of you get told that when you have this, you have to, add 360 or factor out a negative, but sometimes in the exam you don't have the time to waste. So I just draw my Cartesian plane like this. I know this is 0 and 360 degrees. That is 90 degrees. That's 180 degrees as well as minus 180 degrees. This is 270 as well as minus 90 degrees. Can you see? That being the origin. Now, when we say 180, this is the same as having minus 180 degrees plus x, isn't it? Just rearrange that. Now minus 180 is over there, and then once we add, we're going anti-clockwise. So this means our angle theta or x is this angle right there. Okay, so this is the third quadrant. And what is sine? Sine is negative, but remember this is squared, times cos of 180 minus 180 minus means we're going into the second quadrant, so cos is negative. And we come down, we've got cos of 90 plus. So what is that? Cofunction of cos is sine, but cos in the second quadrant is negative, so will be its coratio. So that's the story right there. So can you see we're just doing reduction formulae and coratios here. This is now times sine x. Doesn't look right. Minus, again, we've got this bracket here. So if we think about it the way we just did, this is the same as writing it as minus 90 degrees plus x, isn't it? Where's minus 90 over there? Then if we're saying plus, we're going anti-clockwise, so that gives us the angle over there. So this is the angle in the fourth quadrant. So what do we know about cos in the fourth quadrant? It's positive. And if it is positive, what will be its coratio sign? Which should also be positive. Now, the last one, we'll see 720. This is 360 times 2. So essentially this is 360 plus. That takes us into, did I have a plus? It's a minus, my lord. Oh, guys, be careful. See, copying things wrongly. Well ahead. So this is 360 minus, that's the fourth quadrant. Sine is negative. All right, good. So we go on and sort it out. So this is squared, so it becomes positive, but multiplied by negative, we get minus 2 sine squared x cos x divided by, here we get minus sine squared x, here we get plus sine squared x. Now these are like terms, so we have minus 2 sine squared x cos x all divided by 0, right? And what do we see there? This is undefined. So this question is often so common, undefined, because a division by 0 is undefined. Okay, but usually the question says solve it says what? Evaluate. Okay, that's good. So a question that says evaluate, it means we want the answer. So it didn't say simplify to a single trigonometric expression. So this is no surprise. If it was saying simplify to a single trigonometric expression and we end up like here, I would be worried that most likely there must be a mistake. But sometimes it's like this. Now, how do we score the marks? Usually the reductions. Remember when we're doing our BODMAS applied, we get marks. Reductions, get marks. And using our correlations, can you see? 5 marks already from just the first step. Okay. Now, this becomes how many marks, by the way? 7. Okay. So we've got 5 marks. And what else do we have? Wait, 1, 2, 3, 4, 5. Okay. So this is 6, knowing that that would be 0, and interpreting that would be easy there. Easy 7 marks. Okay, very nice. Okay, let's go on, guys. So this is just to highlight the fact that There's a 3-step approach works, guys, and you need to master it, because this one in particular is 80% of all reductions that we're going to do. Even any form of simplification, it's heavy on that step 1. Anyway, we're given this reduction here, this identity, and we are to prove that identity. Obviously, we want the complicated. We see all the angles are single. There's a double angle. On top, we've got brackets. So if we've got brackets, it's more complicated. So we always try to take the complicated side, and we try to simplify it. So this is 1 minus 10a into cos a over cos 2a. Okay, so what does this get us to? So we can just FOIL this out nicely. So sometimes when you do it, you just do it. You don't have to worry about it. So this becomes cos, this is cos a over cos 2a minus 10a times cos a over, actually this becomes a denominator for both. Okay, easy. And then we see that we've got like terms here because the denominator is the same. So we write cos 2a, this one becomes cos a minus, now we have 10a times what am I doing? This is 10a cos a. Okay, take it step by step so that mistakes don't become your problem. And then what do we see, guys? After doing our brackets off, that was step 1. We ended up with like terms. We handled them, usually the common way. Now what can we do here? Can we factorize anything? Well, we could take cos a out if we want, but what does it help us with? Not much, isn't it? And then if we look here, we essentially are going to have 2 terms, because this expansion always yields 2 terms. So we might as well keep those 2 terms there and not try to eliminate them. Anyway, even if we factorize, we'll still gain 2 terms, isn't it? It's going to be 1 minus 10a. But let's see, this is cos a minus, we can use our identities here. 10 is sine a over cos a times cos a. All of that is divided by cos 2a. We can call this one cos squared a minus sine squared a, purely because we can see in the denominator we've got sine and cos, so we might as well do it in terms of sine and cos. Now these ones are common, so they divide to 1, and 1 is invisible. Okay, so this is a minus sine a over. Now what can we do here? This is a difference of 2 squares, so we factorize using dots. So this is cos a minus sine a into cos a plus sine a. Okay, now what do we see? Again, these are common, so they do it. And what do we end up with? With just 1 over cos a plus sine a. Okay, that's it. All right, you can see that with this, following this pattern, every time you want to unlock something, check what you can do. Is it possible there? And how, of course, being careful to not just do it however you want, because it may become longer than you want. So trying to be as close as possible to what you are looking for. It makes life a lot easier. Okay, so what is important here, guys, is using this 10 identity and this one here also, expanding that cos 2a. Any factorization is mark worthy. How many marks were we scoring here? Just 3 marks, and that's it. Okay, so first of all, mistake in there. We need to conclude that this is equal to the right hand side. Do not take anything for granted. Okay, guys, so this is very simple. Again, we needed to answer the question. We needed to answer the question. Now let's see, this is 5.3.1. So let's do 5.3.2. So it says write down the maximum value of this whole thing. So we've got 1 over sine A plus cos A. So how do we get the minimum value? The maximum value here. Now this means we want this to be the biggest, right? It can be. So it means these two must be the smallest they can be. But now the question is, what do we know? Well, we know that, for the maximum value, it is such that we have 1. The numerator, there's nothing we can do about it. But sine A must be as small as possible. Usually the minimum value for sine A is -1. Plus into the smallest for cos as well, it's -1. This is, us using our knowledge of functions. Obviously this may be crazy, but who cares? So this is -1, which is -2. And that's it. So we can just say this is -1/2. This is the best I can say. So that should be the smallest value there. Okay, all right, okay. So how many marks? 2. So knowing that that denominator will look like that, and that would also be, but anyway, the question said write down. So this becomes your side calculation. Or should we say it becomes the rough work. And this becomes the answer that we need. Yeah. So that's it. This is our rough work that helps us to work it out. Of course, questions of this nature are not necessarily standard grade material, isn't it? But they're not too difficult to get to. So this means 2 marks for the answer. Because when the question says write down, but this is the knowledge we need to keep in mind, that sine's minimum, when it is not shifted, is like that. Cosine's minimum is like that. And obviously, in a question like that, this is the best approach, okay? Now let's do 5.4. 5.4, we've got sigma starting from 38 degrees to 52 degrees of cos squared angle A. Now this is sequences and series, okay? So think about it. Like I said, trigonometry is more like algebra. In fact, it's algebra. Think about that always. So this is sigma starting from 38 degrees to 52 degrees of cos squared A. which is going to be equal to, we substitute a there, this is cos squared 38 degrees plus cos squared 39 degrees. Remember, we need just 3 terms, plus cos squared 40 degrees plus dash 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 plus this one is going to be cos squared 52 degrees. Okay, that would be the last one. Nice. So what do we see, guys? Obviously this gives us the vibes of an arithmetic series, because we can see here that these angles increase by 1. So even if we take this and that and that and that, technically the increase between them is quite fairly constant. So there would be a common difference here between these ones. All right, okay, all right. Again, this takes a bit of a leap of faith, isn't it? Because it would be like, but how sure are we? Well, we are sure, because if we take the actual value here and the actual value here and compare them, there should be some constant or common difference. Okay, all right. So what do we say? We can say this implies, maybe it does not imply. We can see that the number of terms here is going to be the top minus the bottom plus 1. So what is this? 52 minus 38 is going to be 14, and then we add 1. So this gives us 15 terms. Okay. So meaning these terms are going to be 15. We can say Sn in an arithmetic is n over 2 into a plus l, isn't it? Yes. So this implies that S15 is going to be 15 over 2 into the first term is cos squared 38 degrees plus cos squared 52 degrees. Okay, so this also implies that S15 is 15 over 2 into, if we look at these, 38 plus 52 adds up to 90. So we can change one into the other, so we can have cos squared 38 degrees plus this becomes sine squared 38 degrees using cofunctions. Okay, can you see our 3-step approach still is here? Now we've got this is 15 over 2. Now can you see cos squared of this particular angle plus the square of sine of the same angle? This is the identity, the square identity, so this is 1. Therefore S15 is just 15 over 2. Nice and easy. So this is something that is suggesting that, okay guys, don't forget paper 1 material, because this is a higher order question, so a little bit of bravery and the ability to look into these things is important. So we're scoring 4 marks. Okay, so obviously guys, substituting into some formula is a mark. Okay, great. And using our correlations, we get a mark there. Then using our square identity is a mark and our answer. Okay, so this is how we score those 4 marks. And if no mistakes have been committed, we have scored those 24 marks. Okay, so trig can be nice, can be challenging, it can be, in between. Of course, here what is missing is the general solutions or trigonometric equations, but it's not a big deal, guys. Sometimes it depends on the question itself, because somewhere, somehow, if it is not asked here, you may find that a question on general solutions may come here somehow. But expect it anywhere in trigonometry, especially between question 6 and question 5. Because question 7 is applications. You will hardly get that, okay? I'm saying you will hardly get that. Doesn't mean you won't get it, okay? You never know what the examiners are thinking. Just a moment. It happens. Alright guys, so let's continue. Get to question 6 nicely. Okay, maybe let's just make this one a graph paper. Just a moment. Okay, so we've got this one. So we're doing question 6. Now, what does question 6 want? We are told here to sketch the graphs of these two functions for this domain on the grid. Okay, not a problem. So what do we have? F is equal to the sine of a half x, and G is basically cos of x plus 60 degrees. Okay, not a problem. So we can see that this one affects the period for the sine graph, whereas the period here does not change. It's an invisible one. So if we look for the period here, you would see this would be 360 degrees divided by a half, the coefficient of x. This gives us 720. Ne? Let me see, yeah. 360 times 2 is going on, okay? So this means we can think of intervals here. That this is going to be the period 720 divided by 4, right? So what does this give us? So 720 divided by 4, not 40, is 180. Okay, so we can see that between two critical values, be it an x-intercept or a turning point, this would be the period of 180. So this concept is very important. Okay, now for G of x, what do we see? We will see that the period is going to be 360 degrees divided by 1, which is equal to 360 degrees. And then the intervals for this one is going to be 360 degrees divided by 4, and that gives us 90 degrees. So this one goes in 90 degrees, but then we have to accommodate that 60. We need to have 60 in there. All right? Okay, all right. So the common factor between these two, just simply take this and divide by that. It will give us 3 over 2. Okay? So that means we need to choose a scale that perhaps has a common factor between these two, right? The common factor would be 30 degrees. So we need to choose 30 as the smallest, because that will still give us 90. It will give us 60. So again, this one may need a bit of skill, but it's not really a big deal. Okay, so this was just you and I working out things before we start. Obviously here the maxima and the minima is just 1 and minus 1 for the both, okay? Because of their amplitudes. So these are things to think about. So there's an invisible one here. So this gives us the amplitude. And then this gives us the maximum of 1, minimum of minus 1, okay? Very important, and that would actually give us the range of that function. Similarly to this one, we can say there's an invisible one also there, and this simply says the amplitude is 1, giving us our maximum at 1, our minimum at -1. Okay, so this is important. So remember guys, of course you don't need to do this in the exam. This is something that you need to know in the back of your mind and be able to perform. Okay, now we just want to draw the graphs. So with the graphs, we just jump in. We just jump in. Okay, and then we go on. So we know that this is going to be 0 at the origin. Now we can decide this is 30, 60, 90, right? So we can say 30, 60, 90. Okay, and we're going to 180. So this is going to be 120, 150, right? And then 180. So this is 1, 2, 3, 1, 2, 3. Okay, 180 there. Not a big deal. Not a big deal. So we still have those ones. I don't really need to write them out. Okay, this is y. We know the maximum goes to 1, so we can make this one a half and then 1, just to make it nice. So this is a half and this is -1, the minimum. Okay, good. Now what do we have to do? We have to do the same. This is 30, 60 minus 90, minus 120, minus 150, minus 180. Okay, you don't really have to write all of them, but as long as one can see what is cooking. I mean, 90 divided by 3 is 30, so that should be 30 right there. Now what do? We sketch, we plot, we do it. Now for the sine graph, easy. We know that essentially the sine of 0 is 0, so it's 0 here. Okay, and then now since the period is 180, it means we'll hit our first critical value, which would be the turning point at 180 this time around. Okay, easy. This is what we're going to see, because this period has slowed down. So usually we could say normally we would get it at 90. Then we say 90 divided by a half, it gives us 180, so it goes there. So this one will come down here also. Okay, so let's draw the graph. Okay, so there's our graph of f, guys. Easy. So here we don't really stress and do too much, but we make sure those points are clear. And then we get to the next one. The next one is the cosine. So cos of 0 is basically 1. But now this shifts to 60 degrees before 0. So this is minus 30 minus 60. It goes up here. So when you understand these translations, it makes life a lot easier. And then the next one would have been at 90, an x-intercept. So we take it 60 degrees, it goes to 30, right? Right. And then the next one would have been a minimum at 180, but now we take it 60 degrees back, it goes to 120. All right. So this is the stuff that we have. And then we go on and say, look, at minus 90 would have an x-intercept, but then we take it 60 degrees. So from 90, we add 60 degrees, that goes to 150. So the x-intercept is going to be there. And then at 180, this is what would be happening at, say, 60 degrees ahead, basically. Because we need to say at 180 it's going to be what was 60 degrees ahead. So from 180, if we go to 60, that would have been 120. So what would happen here? That would be minus a half, isn't it? Yes. Minus a half is going to be there, so it's going to come down here. Very nice. So we've got the end point. Of course, here we didn't end it nicely. So let's see what happens at 180 is what would have happened 60 degrees ahead. So let's see, 180 plus 60 degrees is 240. Say cos of 240, it's minus a half. So this one comes up here. Okay, so let's join the points. Okay guys, so there's our graph. So we just simply label, this one was that was G, this one was F. Okay, nice and easy. So this is how we draw those graphs. They look simple, no need to stress about anything. All right, so can you see guys, once you know what's cooking, your life becomes a lot easier. Your life becomes a lot easier. Okay, all right, okay. So we've done 6.1, so we're stealing those 6 marks. Obviously, first is the 3 marks of the shape, and then any one of the intercepts, be it x or y. Maybe we can say any one of the x-intercepts, but usually just any one. Shape, and then any one of the turning points, meaning the maximum and the minimum. So usually 3 marks. Same for this one. This would be the maximum right here. That would be the shape. And that would be the intercept at the origin. So this is how those 6 marks are scored. Nice and easy. All right. Good. Let's just remove those ticks because we may need the graph for the next question. Now, that was 6.1. Okay guys, so it's getting a bit busy-ish now. That was 6.1. Okay, good. And then we're going to do 6.2. 6.2, we're going to use our graph to interpret. So this is the graph interpretation. Easy, let's rush through it nicely. So I've got 6.2.1. We need to write down the range of the graph of f. Can you see all our groundwork is good? So we know that the range is equal to y such that, a set of y values such that y is less than or equal to 1, greater than or equal to minus 1. Okay, and that's 1 mark. Of course, you can write inequalities, you can write the interval notation, it's not a big deal. 6.2, what do we have? Okay, 2 marks for this, not a problem. 6.2.2, it says state the period of G. See, G did not change, so this is 360 degrees. Easy stuff, 1 mark. Then 6.2.3, we need to determine the values of x for which these are equal. As you can see, this is 4 marks. Now, is it possible to just use our intuition there? We can't. We need general solutions here. At least that is what can help us here. Otherwise, we will not be in a position to answer this question easily without needing our general solutions. So for me, this is this position right here. That is that position. So we need to work it out, basically. So let's see. Okay guys, so I'm on duty, so I'm getting a bit distracted. It looks like I'm not gonna finish on time. All right, so we need to determine those values. So basically guys, general solutions, but sometimes you may not need a lot because it's just one point of intersection in the first quadrant. Remember, from 0 to 90 is the first quadrant, so that is a point in the first quadrant. So literally we don't even need the general solutions per se. We can just equate the two, but always try to use the general solution technique so that you don't lose out on other solutions. Okay, so what are we doing here? We're going to say, well, f of x equals g of x implies that we've got sine of a half x equals cos of x plus 60 degrees. Now remember, our three-step approach, what can we do? We've got correlations, so if we've got sine and cos like that, we can actually represent each one in terms of, sine, essentially. So this could be sine of a half of x. This one was originally sine of 90 degrees minus the sum. See, this is very nice. So this implies that we've got sine of a half of x equals, we simplify this one a bit more. So 90 minus 60, this is basically 30 degrees minus x. Easy. Now when we've got sine, we can equate the angles. So this implies that basically a half of x should be equal to, what is this? It's going to be 30 degrees minus x plus k, 360 degrees. Okay, or x, obviously guys, we just look and see. We just look and see, but I'm trying to see what is cooking. Do we really need the other one? But let's just check it out. There's nothing wrong with doing the right thing. So it's going to be 180 minus this, 30 degrees minus x plus k, 360 degrees. This is where k is an element of integers. I always like to do my general solutions for points of intersection to avoid trouble. But if you're not confident, you may not need to. Okay, so what do? We transpose the x, so a half plus x is going to be 1,5, right? Right, so that is 3 over 2x is equal to 30 degrees plus k times 360 degrees, or x is equal to 180 minus 30 is going to be 160 degrees. No? 180 minus 30 is 150 degrees. Then plus x is equal to plus k times 360 degrees, where k is an element of integers. As you can see, x and x will do us the honors, so there's no solution in there. So this definitely is the solution. So sometimes go through the process, guys. Don't always assume you're going to have an easy way through here. So what we see there, this is going to be as good as 30 by 2, that's 60 divided by 3, that's 20 degrees. Plus k times, now this one goes to, we've got 2 by 360, that's 520 divided by 3. What does that give us? So 1 plus 0,5, yeah, that's 3 over 2. Ne? Then we've got 360 divided by 3 over 2 it gives us 240 degrees, where k is an element of integers. So can you see, guys, this is an angle in the first quadrant, so this is the one. It should be the one. Okay, so we are sorted. Just trying to make sure everything is proper. Yes, so we know that if we look on our graph, we can see that this one right here is 30 degrees, right? So that is definitely before 30, so that's 20, so it makes sense. So what are we looking for? The x values. So we can say therefore x is equal to 20 degrees, because that's the only point that we can see on the graph. So general solutions for me is the best way to go about doing your business. And as you can see, our three-step approach is still being applied heavily. So obviously using our co-ratios here is very important. Maybe we can get a mark for that, and then we get a mark for this business over there, and the third mark for this one over there, and the last mark for the answer. I'm not too sure really how this is marked. Sometimes it gets a bit complicated, but I often find the general solution route as safe, because you don't miss any other points of intersection that we need. All right, folks, this is all good. So we leave it there. So we've got 6.2.4. Now we are told here, if h of x is g of x shifted 30 degrees to the left, write down the equation of h. Now we can do a side calculation here, because we know that h of x is going to be equal to g is cos. Now instead of x, we write x plus 30 degrees, and then we add the 60 degrees. Right, this is the same as cos of 90 degrees plus x. Now cos of 90 is the same as minus sine x, using our co-ratios. So all we write here is just h of x is equal to minus sine x, because the question said write down. Easy. But now here's the problem. 3 marks. Does it make sense? This is a very stupid way of asking the question. Sorry guys. Just have to call out some nonsense sometimes when it is nonsensical. So how can you say somebody must write down and all of a sudden there's 3 marks? Does it make any sense? It really does not. So for me, I would say, well, if the examiner decided the answer only, it's okay. So maybe the distribution of marks is to say the negative is a mark, and then using co-functions there to get that business, because that was a translation first and then co-functions, so that is worth 2 marks. So perhaps answer only 3 marks, but this is unusual. We don't get an answer only for a 3-mark question being the question. But yeah, some examiners are really careless, because at the end of the day, this is not smart at all. It's actually very lousy, if we can call it out as such. I am sorry if it rubs someone wrong, but the idea is we can't have such a very weak question being posed. Rather say determine. That's better, because then 3 marks, it means a calculation is also accommodated, because that's what you would do. There's no way you would just look at this without working it out and get the right answer, and that's it. Inspection is not truly going to be quite fair there. Anyway guys, let's not overly explain this. It's done. Let's just finish up. We don't have much time. Maybe let's seal this one there and then go back to our normal page template. Great. So now what do we see? Question 7 is usually the question that is pretty interesting in this topic, because we are doing application of calculus, of trigonometry, as we often get a question on calculus and then we do applications on paper 1. So this is the equivalent of that optimization type of question. Now it says in the diagram below, MP is a vertical tower. So we can see those angles are 90 degrees. MQ and MR are wire ropes used to stabilize MP and are each 19 meters in length. So we can see that those ones are equal. So if they are equal, they're creating an isosceles triangle. You see this big triangle here is isosceles. This big triangle becomes an isosceles triangle. Okay, sometimes this one is not a very nice. I'm gonna try to be on the line. Okay, that's the one. That's the one. That's the one. Yeah, doch. There. So we can see that this becomes an isosceles triangle, suggesting that this angle and this angle must be equal. But now what do we see? We see that this angle is actually beta. So if this is beta, this means this one also is beta. So we're going to do the same notation and say, well, that is beta, that should also be beta. Because we can see those sides are equal. Nice. RP and Q are in the same horizontal plane. Okay. Okay, I like this when it is shaded like that so that we can see without being confused. All right, so nice. It says now the angle of elevation of M from R is Y, so it's indicated. And we're told here that RPQ, it's already indicated, is X, and MQR is beta. So that's easy. So we know that this is also going to be beta as well. All right. Now, what do we do? Usually the triangles that have an angle, we can determine the other angle, right? We can determine this angle. And that angle is going to be 90 degrees minus y, okay? From three angles of a triangle. Good. But this one is only that one. And nobody told us anything about those two sides being equal per se. So we can leave that one out. But if we think about it, okay, let's not think about it. It's going to be a dangerous move. But is it possible that these triangles are congruent? Yes, they are congruent. Why? We've got a right angle here. The hypotenuse side is the same. And we've got a common side. So these two are congruent. So if they are congruent, it also means that is equal to that. So we need to always be on the lookout for these things. So guys, cannot overly emphasize the importance of inspecting these things. Okay, the helicopter just arrived, so I will need to run. So let's move quickly. So we need to prove that the area of triangle PQR is given by this, and we can see here that there's a cos squared y in there. All right, okay, all right, and this is now a heavy 5 marks. This is already suggesting we need to do our work nicely, and simply we need to prove indeed that PQ is equal to PR, because we can use the area rule using angle X in there, because we've got sine X. So angle X and those two sides included angle, because we don't need the other things. Because as we look here, there's no beta, so we don't need these angles on the side. Okay, great. So let's do 7.1. What are we going to say? Well, we're going to say in triangle, say MRP, okay, and MPQ. Okay, I don't know if it is necessary, but we need to say it. What do we know? We know that MP is equal to, in fact, why do I even want to say that? I can just say MP is common. Right. And then we know that basically MPR is equal to MPQ equal to 90 degrees. That is given. Okay, great. And then what else? We know that basically MR is equal to MQ, right, equal to 19 meters. Is it 19 meters? What was that? Yes, 19 meters. That was also given. So what do we say? Therefore, triangle MRP is congruent to triangle MPQ. Now this is the right angle, hypotenuse, and the side, isn't it? So that's another condition for congruency there. So what did we want to get to? We wanted to prove that indeed PR is equal to PQ. Now these are the corresponding sides in congruent triangles. Nice. So we've set this one nicely, and now we're ready to cruise. What do we want? We also want to use this triangle right there to find MP actually. So we can say, but we know that essentially sine, do we want to use sine? We need to use cos, because the most important thing is to know that this is the adjacent and we know the hypotenuse. But we know that cos of y is equal to, now PR over MR. Okay, maybe let's say this one differently and say the cos of angle MRP. So this is easy to see. Maybe we can just write here C triangle MPR. Okay, good. Just trying to point reference to what we are doing. So this is cos of y equals, now PR is what we want, divided by MR is 19. Okay, so we can conclude that therefore PR, when we cross multiply that there, it gives us 19 cos y. Okay, so once we sort this one out, what do we say? We can say then, now what are we going to say? We know that area of triangle PQR is going to be equal to half PR times PQ times sine of RPQ. Okay, so what is that? That's the sine rule. That's the sine rule. Okay, now what do? We sort it out. So this is a half PR. What did we say? This is 19 cos y. Now we said PQ and PR are the same, so this is also 19 cos y times sine of angle x. Now what do? The numerators will multiply, and the denominators, these are all over 1, so this is over 2, so 2 comes down there. So 19 by 19, what is it? 19 squared is 361. Then cos, we'll write it as it is given to us. So sine x times cos squared y is done. Okay, easy. So this is very important. I know this one looks a bit longer, but some examiners, when there's too many marks, it means there's a lot of work to be done. All right, so everything was given here, guys. There was nothing really interesting, but I would give a mark for proving congruency and deducing that. That is worth 2 marks. Okay? And essentially using trigonometric ratios there, that is the 3rd mark. And then substitutions into the area rule is the 4th mark. And indeed, knowing that we can substitute this twice is essentially the 5th mark. Everything else is history. So what are we doing here? 5 marks. Nice and easy. So I hope you can appreciate, guys, all of the work that needs to be done. And guess what? Everything is doing the 3-step approach. Lovely stuff. Okay, let's finish this thing before I get pulled out. Now we need to show that RQ is equal to 38 cos beta. Now we can see here that, okay, this is this side now. Now that is going to hurt, but what is good is that we have now cos of beta. So this means we're moving into the red triangle now. So if we move into the red triangle, what did we notice? It is itself isosceles. So this means we need this angle. And that angle is going to be 180 degrees minus 2 times beta. Right, from 3 angles of a triangle. Saying that this is beta and that is beta, and then we get that. But of course we need to justify that angle, because for 6 marks we can't just assume somebody understands. Okay, great. So let's do this one here. 7.2, we can just simply say in triangle MRQ. What do we see in there? We will see that this angle MRQ must be equal to MQR equal to beta. Now these are angles opposite equal sides given OMR is equal to MQ equal to 19 meters. Okay. Sometimes the reason needs to be comprehensive, because to say a lot of things separately, it's a waste of time. Sometimes you've got to summarize things nicely by putting everything together, integrating. Okay, what are we getting to? We're going to say this implies that basically angle this implies that angle RMQ plus angle MQR plus angle MRQ must give us 180 degrees. This is sum of 3 angles of a triangle. We're still talking about that. Just a moment. Okay guys, so that is the story. So we can just do it nicely. So RMQ plus beta equals 180 degrees. So we can conclude this. RMQ is going to be 180 degrees minus 2 times angle beta. So that is important, although we know it quickly, but we have to justify our way through, because these marks are suggesting this is important to show. Now, what are we doing? We want to show that RQ is what we see. Now, folks, to use the cosine rule would be a punishment. Yes, you can use it. It's okay. Because we've got that angle, we've got the 2 sides. We can use the cosine rule, but the easier one is the sine rule here. We can say then, now remember looking for RQ, the side. So we can say then RQ over the sine of the angle opposite that. It's going to be RMQ. Okay? Yes, Yes. Now, what are we saying? We're not saying anything. This is equal to, we can choose any one of these other two angles. So let's choose the one that was already given. So this is going to be MR over sine of MQR, because that was given. So we know that this is the sine rule of triangles in this triangle. So RQ is what we want over, this is now sine of angle beta. No, this is the sine of 180 degrees minus 2 times angle beta is equal to MR is 19 divided by sine of this angle beta. Now we just cross multiply that there. So we go on and see. Now what do we have? We've got RQ is equal to, maybe let's write it nicely here, is going to be 19 times the sine of 180 degrees minus 2 beta over sine beta. Okay, so we can simplify this. Now this is 19 times, now this is the angle in the second quadrant. We're doing reduction formulae from our 3-step approach. This is as good as sine 2 beta all over sine beta. Okay, we go on nicely. So some steps can be quite intense, okay? So have the patience. 19 into, this is a double angle identity. So this is 2 sine beta cos beta all over sine beta. All right, so what do we see? Now the things that must can be done, eh? So RQ is equal to 19 times 2, that's 38, isn't it? Cos beta. CB is done. So this was a bit of an essay. Those are the types of questions that sometimes will take you to heaven and back to earth, okay? So this is very important. So this statement is key and the rest is important, but the most important is that angle, because this is a grade 11, is it grade 8 reason? So it's not such a big deal for grade 12. We apply it, but we normally don't get a mark for it. Okay, so those are the first 2 marks. And then essentially, what are we going to do? We probably could get a mark for setting up the sine rule in that triangle like that. And then we get a mark for substitutions, easy 4 marks. And then for the reduction formula 5, for the compound angle, the double angle identity, the second mark. And that's it, because this was already given. So 1, 2, 3, 4, 5, 6. So easy 6 marks. So guys, I hope you practice well and do your absolute best. Good luck for tomorrow. And of course, use the channel for most of the videos, especially the technical questions. Look at the KZN trial paper from last year, the Mpumalanga paper from last year, and many other papers I have done, essentially. Some from the Free State, some from, everywhere else. EC, yeah, there is a paper too that I've done for EC, I think 2021 trial, something like that. You look at those papers and you see the level of technicality in some questions, and you get it done. But most importantly, do not ignore that 2005 paper I showed you. Please, especially the Euclidean geometry section and the analytical geometry section. Those two will haunt you if you're not there yet. But the trigonometry part, okay, it's okay to look at, but I don't think it's too complicated. Most of your trigonometry doesn't really look as strange as that. But be careful of proofs of the area rule, the sine rule, and the cosine rule. It is examinable, so you can get it at some point. So be ready to hustle that. Otherwise, look at the proofs of, the circle geometry, proportionality theorem, as well as the similarity don'ts. Please make sure you don't go into that exam not knowing those proofs. If there's anything you may want to spend time doing today, is actually playing around those proofs and taking some basic questions on them, using your study guides or whatever, just to set the mood right. Then when you feel you're okay, then you can start challenging some Euclidean geometry questions, because usually Euclidean geometry, no matter how ready you may be for it, it has a tendency to give you quite a nightmare. Everyone gets a nightmare from that, because if you don't know what the memo is saying, you will not know what to do about some questions straight away. It takes a moment, and that is the time you probably do not have. But remember, tough questions in Euclidean geometry essentially involve what is this? They involve simultaneous equations, but the trick is you need to find those simultaneous equations yourself, meaning you've got to derive them using Euclidean geometry means. Then you substitute the common ones. Always look for the common side, or at least a common angle, whatever makes it easy to set up an equation where you can substitute something into the other, meaning you look for either a common angle in two separate structures or triangles, or you look for a common side, or at least a side that would be equal to another side in another triangle, so that you can set up an equation where you can substitute one into the other. And then as you simplify, you end up where you need to go. So that is the trick I can say for that higher order subplexity type of question in Euclidean. It always needs simultaneous equations. It always needs two structures. You need to find some common side or equal sides. Then you use them to substitute one into the other. And that's how you sort it out. Obviously, it's not as easy as I'm putting it, but usually, if you've got the idea, you've got the concept. So if you know what to look for, you'll always get it right somehow. But trial and error here and there might take you across the river as well. So don't think you're just going to have a clear view of everything. You'll just get an idea, follow it. It might take you to the destination you're supposed to get to. Or sometimes you get stuck and then you change the plan. You take a detour. That's how life works, guys. You never always have a smooth road from the beginning to the end. Sometimes it gets a bit bumpy. Even if it's smooth, you find that there's an accident on the road. So you get stalled a bit. So that's just how it is. Anyway, folks, before I say more than I'm supposed to and waste your time with nothing, obviously, good luck for tomorrow. And please rest tonight. From 11 or at least 12 minimum, the maximum is 12 midnight. You must go to bed and wake up after 6. Okay, maybe 6:30 or so. Then you do your things to 7, and then you eat, and then you get to your place of your examinations, of course, depending on how far it is. But you need some 6 hours of rest. In the morning, if you have to do anything in the morning, you just look at your theorems, you look at some techniques that you need to use to prove them, because if you start solving other questions, they will bombard you with pressure and make your brain tired. You don't want something that you need to actively do. You just want something that's already done, but you just want to make sure it's fresh in your mind, because here's the first thing you need to do in your paper, just to give an advice on how to do on that paper. The first question is to do the proofs. Don't answer any other question. Start with the proofs, because those are the ones that can horrify you when you're under pressure and you don't remember what to do. While they're still fresh, those are easy big marks. Go start with the proofs. Leave everything else. Then after the proofs, the first section to start with is Euclidean geometry, because you can't do Euclidean geometry in a hurry. Do that section while you still are okay. The next section to do is trigonometry. It has a tendency to be annoying, and you can't speed up in trigonometry, especially after question 5.1. Everything gets a bit complicated there. You want your brain, while it's still fresh, it's under no pressure for time. Then the next one is analytical geometry. Remember, analytical geometry, most of it, you can do it in a hurry. It's usually straightforward questions. Yes, there are some higher order questions, but they don't stall you from going as fast as you need to in getting most of the other marks. And then the last one for you to answer is statistics, because that thing is very easy. You can even speed up there because it's all about calculator work. But don't take it for granted. Give it its own time to do it, but you can do that section last. There's no need to start there, okay? Because there are not so many marks anyway. Even if you get those marks, they don't really make so much of a difference if you mess up in the big sections. Anyway, guys, I've told you what I think is best for you to do, and of course you yourself know what you're strong at and what you want to do. The plan is up to you. I'm only suggesting an approach, and hopefully it works if you use it, and hopefully also yours that you would choose would also work. Otherwise, I will just drop a question here and there, maybe during the day and maybe some early evening, just, to consolidate for those who probably need a bit more. But I normally do not appreciate, in fact, I don't like to interfere, because the one thing that is important is for you guys to do the actual work yourselves than to watch someone else do it. But of course, for those who are already prepared but they need something fresh, maybe an idea to, put the nuts and bolts tight, put a bit of talk in there, this can work because they're already at ease. So watching these videos is no time wasting at all for them, rather than to undo what they have read by confusing themselves. But for those who are really not so strong, it is not advisable to watch videos at this stage. This is the stage where you do the actual practicing. And if you don't know what to practice, then you can use these videos. When you see a question, you freeze the thing, you practice, and then you see how it's worked. And maybe see if you're not gaining any ideas on how to deal with similar questions. And immediately you sort that one out, take another question of the same sort. For example, for doing this question 7. You freeze, you do, you struggle, you see how I've done it, and then you feel you understand. Take another question and try to approach it in the same manner. Don't pressurize yourself with time, but make sure you are meticulous and you can solve. You will see, man, something is just going to click once, and you will do anything when you get to these questions. Then, of course, the rest, guys, is too much. If you did not do enough work already throughout the year, this is going to be horrible, because there's no quick way of fixing this one. But you go through it nicely. Of course, there's a statistics section here. Pretty easy, pretty boring, so you can practice if you want. It's not a big deal. So yo senthethe kakhulu futhi hayi ngeke ndiyaguga. Okay guys, goodbye and good luck. Yes, here and there I might drop something extra. It's okay. But this is my formal revision for you guys. And I'm not going to waste time with Euclidean geometry because you guys know it. But maybe I must just do this question here, perhaps. Maybe these last few questions, just to give you a little bit, It wouldn't hurt, but let's see if I will find some time. Goodbye for now.